Okay guys, welcome to 2.1 Exploring Parallel Lines for Foundations of Math 11. Let's go over some key terms. A transversal is a line that intersects two or more other lines at distinct points. Alright, so an example of this is if we have two lines like that, then the red line passing through like that would be the transversal. An interior angle is basically any angles formed by transversal and two parallel lines. So notice these two lines right here, they're parallel. That means they'll never cross. And this is our transversal right there. So the interior angles lie inside the parallel lines. So AB are interior angles, DC are interior angles. All these inside here are interior angles. What about an exterior angle? Any angle formed by a transversal, again this is a transversal, two parallel lines that lie outside the parallel lines. Okay, so notice these are the parallel lines and the angles are on the outside here. Alright? Corresponding angles, like we have here, again we have two parallel lines and a transversal, and we're going to have an angle that's interior and an angle that's exterior. And notice that the angles, they lie on the same side of the transversal, so they're not opposite. Okay, so they also make, corresponding angles also make an F pattern, right? So notice the F pattern right there, and we have one in and one out. Okay, let's look at the investigation. So draw two parallel lines, draw a transversal that intersect the parallel lines, measure the 8 angles, and record the measurements. Well, I'm going to give you the measurements, so let's just draw what it says first. So we have our two parallel lines, and then again this is our transversal. Alright, and now let's put in some angles. Okay, so we have this angle is 110 and this angle is 70. Alright, together they're supplementary, they make a 180 degree angle, a straight line. Now, this angle right here is also 110 because it's vertically opposite of this one. This one down here is corresponding to this angle. So this is corresponding to this. They make like an F pattern. Alright, so that means that this one down here is going to be 70 degrees. This one over here is corresponding to 110. So this one's going to be 110. Oops. Alright, and again on the other side we have over here this is this angle right here is corresponding to this one, and this one's going to be corresponding to that one. Okay? So let's just fill those in. Okay, so there is our diagram. Now let's move on here. We're going to draw two lines that are not parallel and a transversal through them. Alright, so let's go ahead and do that. So we have, there's our first line, and there's our second line, not parallel. That means that they're eventually going to cross. And let's draw our transversal right there in the red, again going through the two non-parallel lines. And now let's add some angles. Now here we have this angle is 120, it's an obtuse angle. This angle is acute 60, and down here it's 110 and 70. Now over here these two angles were the same because they were corresponding. Over here you might ask yourself, well, these ones, shouldn't they be corresponding? The answer is no, because the lines are not parallel here. They're unparallel lines, so the corresponding angles, or the rules that we went over above, they only apply to parallel lines. Right? So since these are not parallel, these angles cannot be equal to each other. So we're just going to be working with this up here and this up here. So this is 120. Vertically opposite angles dictate that this angle right there will also be 120, and vertically opposite right there is going to be 60. Vertically opposite there is going to be 110. And of course over here it's going to be 70. Alright, so because the lines aren't parallel, we have to treat each case as separate right now. We can't use the angle transversal rules because the lines aren't parallel. When parallel lines are cut by a transversal, what conjecture can you make about the relationship between corresponding angles? Alright, so take a minute and think about this. Conjecture means prediction. So basically, when a transversal intersects two parallel lines, corresponding angles are equal. Write the converse of the above conjecture. So what does that mean? Well, that means write the opposite of the above prediction, alright, over here. So basically, when a transversal intersects two lines and creates corresponding angles that are equal, the lines have to be parallel. If we look at a diagram here, we have a transversal and two lines. If A equals B and they're corresponding, these two lines right here, they have to be parallel to each other. What do we know about vertically opposite angles? Well, vertically opposite means they're directly opposite from one another and they're equal. What do we know about angles on a line? Well, they add to 180 degrees and that's called supplementary. Let's take a look at a diagram for both of these examples. So if this angle right here is 50 degrees, this angle right here is directly opposite, so it's going to have to be 50 degrees. And this angle over here, this whole line makes 180 degrees, so this angle over here has to be 130. Even though it doesn't look like 130, it should be 130. Okay, so let's review. When a transversal intersects a pair of parallel lines, like these lines are parallel, corresponding angles that are formed by each line, one in, one out, they make an F pattern. They are equal. If a transversal intersects a pair of lines creating corresponding angles, those pair of lines, so this transversal intersects these two lines and these are corresponding, that means these two lines have to be parallel. Alright, so when a transversal intersects a pair of non-parallel lines, the corresponding angles, so right here we have two non-parallel lines and this transversal, the corresponding angles are not equal.